I'm going to try to come up with some daily puzzles. So let's read the first sentence and see what fits in here, what fits in here, and what fits in here. Only a number or value may turn into or give a this or this of a function. Anyone wants to give it a try?
Critical
Number, very good. Oh yeah, you're right. There is no point in writing number twice. Of course. Thank you. Only a critical number. Good. Value may give or turn into a this or this
minimum or maximum
of a function, of course. Minimum or max, max or min, doesn't matter. Perfect. Awesome. A number value is a of x for which the of a function is this or this. A
critical
yes, of course, is a blah 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 of x.
derivative
Value of x for which the of a function is this or this.
If the derivative of the function is 0 or undefined.
Awesome. Of a function is 0 or undefined. Excellent. So a critical number is a value of x for which the derivative of a function is either 0 or undefined. Awesome. A function without cannot have a this or that. Anyone? A function without, very good.
minimum or max.
Cannot have a max, min, very good. Although there is no guarantee that if it has, but it's guaranteed that if it does not have critical numbers, cannot have a max or a min. Awesome. The of a function determines the of increasing, decreasing, and all blah blah of that function. Of that function.
derivative
Very good. The derivative of a function determines the increase of increasing, decreasing.
Slope.
Intervals. So the derivative of a function determines the intervals of increasing, decreasing, and all possible, if you want,
Minimums and maximums.
very good. Maxima, minima, plural, very good. Max, min of that function. Awesome. Great job. So that summarizes everything we discussed in chapter 3 so far. Okay, so I would like us to, I'm going to share my screen, and I would like us to go to, I still want to work on a couple of problems, or at least one from 3.1, which is page 277. Unless I'm logged out, I hope I'm not. Okay. So we chose, I don't remember which problem, I think it was 43. We can choose another if you'd like to choose another to find the relative max or min. No, we're not sketching the graph in this section. We will in the next one, but not now. And I would like to look at optimizing revenue. Optimization means max min. Okay. Can anyone give us here, let's say, an example of a critical number that is definitely a relative min or max? A relative min. Can anyone point out any value here?
XA.
Which one?
XA.
Yes, very good. So this is a relative minimum. Also, for this function that we are looking at, this is the smallest value possible. Therefore, x sub 8 is the relative minimum as well as the absolute or global. So I'm going to write it here. So x sub 8 for that problem is also absolute, also called global, because it's the absolute minimum, absolute minimum or global minimum for that function. There is nothing smaller than it. Good. Can anyone give us a relative max?
X10.
X10 is an absolute max. Thank you. And it's also, it happens to be the largest possible or the highest peak if you want. So this is not only the relative where the function exists on both sides or local, regardless of what you want to use, it doesn't matter, but it's also the absolute maximum. Perfect. So would you like to choose, let's choose a rational function this time, 55, just to find critical numbers and see if it has a max or a min. So let's look at 55. And this is on page 277, and we have g of x equals -8 over x squared plus 1. Now we have an idea of how these rational functions look like. But regardless, we are asked to find max min. When I'm asked to find max min of a function, what is the first thing I need to determine?
Is it the domain?
We're not graphing. We're only asked to find max min.
The derivative.
Yes, so that is the first thing, g prime of x. Now, I prefer, it's up to you, instead of, because there is no variable at the top, it is smarter to present this function like this. It's easier to differentiate. I'm not saying do not use or I have anything against the quotient rule, but there is no x at the top. This will make it much easier. So if we go with that, can anyone differentiate this for us?
Is that going to be 8 and then 8x squared plus 1 and then to -2?
Times the inner function prime, always.
-2. No.
The inner function prime,
2x.
2x. Now I bring this back to the denominator. So this is 16x over x squared plus 1 squared. So it would have taken you more time to apply the quotient rule every time you notice that there is no x in the denominator, it's just a constant. Always think in these terms. It will make your life easier. Again, I don't have anything against using the quotient rule, but you have to remember that -8 prime is 0. So I have students who write 0, but then still multiply by x squared plus 1, and they don't get 0. So that's why I strongly recommend this. Good. So this was the first step. When I have to find max min, I have to find g prime. What is the next step? What am I analyzing next? What am I doing now? What do you think? Anyone?
prime is 0?
Yes, I said g prime equal to 0, and I said g prime of x equal to undefined. So let's see if this gives us anything, and if this gives us anything. That's my second step. For the max min, I find the derivative, and then I set it equal to 0 and undefined. Okay, so when I set this equal to 0, 16x over x squared plus 1 squared equals 0, do I get a solution or not? When is a fraction 0? So when is a divided by b 0? A divided by b 0.
When a equals 0.
Of course. Thank you very much. Only when a is 0. Can this be 0? If it can, tell me which x.
X equals 0.
Oh, of course. 16x equals 0 means x equals 0. Perfect. So now let's analyze when is a fraction 0. I'm sorry. When is the fraction undefined? We analyze when it's 0, when the numerator is 0. When is a fraction undefined? Because this is a fraction. That's why we're talking about fractions.
When the denominator.
Very good. When b is 0. Awesome. So x squared plus 1 squared equals 0. Is it possible? Can I get any x from here? Any value of x? No, indeed. This is never 0 because it's a positive number plus another positive number. It can never be 0. Good. So we did find a critical number, just one. So g of x has one critical number. Good. Now the question is it a max or a min? I don't know. Maybe, maybe not. So I have to create the table. I put g prime of x in the table.
Sorry, can you pause for a second?
Say that again.
Can you explain how do you get x equals 0 for the critical number? Just one more time.
Yes, yes, of course. A fraction is 0 when the numerator is 0. When you set 16x equal to 0, you get x equals 0.
Why did you set it to 0?
A fraction is 0. That's what I have to do to find critical numbers.
Ah, okay. So this is every time you try to find max min, this is this step you're gonna take. These are the steps.
Yes. Yes. So we're asked to find critical numbers. We wanted to identify them at that point. So in order to find critical numbers and max min, we found the derivative. We set it equal to 0, and we set it equal to undefined. So we determined the derivative. We set it equal to undefined. We set it equal to 0.
Okay, cool.
Perfect. Good. So we have 0, negative infinity to infinity. I hope I didn't ask. But yes, the domain is all real numbers because x squared plus 1 will never be 0. But the derivative is 0 here at 0. So let's look at the derivative and find its sign to the left of 0. So in here, tell me which quantity you will not plug in anything in. So you have to plug in -5 and +5, let's say. Which piece of all this you will not bother with because it's always positive? That's it. It will be a waste. Excellent. It will be a waste of time to spend a second on the denominator. That's always positive. So when x is -5, what is the sign of the entire derivative?
Negative.
Perfect. When x is +5, what is the sign of the entire derivative?
Positive.
That's it. So then the function has to be decreasing and has to be increasing, as we know. If the derivative is negative, the function is decreasing. If the derivative is positive, the function is increasing. What type of point is this? And now I will plug it in because I want to determine that point. So this is g of x, g prime, and then g of x. So let's plug in 0. Can anyone plug in 0 here and tell us what you get?
It's -8.
That's it. So can anyone tell us what type of point is 0, comma, -8?
It's a minimum.
Yes, it's a relative minimum. As we see, the function decreases, then it has a 0 slope, and then it's increasing. So it has to be a relative minimum. Perfect. Awesome. Any questions here? Okay, so let's look at an optimization. Let's say we want to optimize the revenue. So, I don't know, 69. And I am on page 3. In the 69, they say the price, y equals price, equals 500 minus 5x, and it's in, no, that's not price, see? So the price is x. I think it's better and easier if I do this. No, I can't. We can see through, so it's not good. Okay, so x is price in dollars, and y equals 500 minus 5x. Perfect. Number of units. Sculptures. Fine. Find r of x. So in part A, they want us to find r of x. And in part B, the total revenue generated, such and such. And find the relative extrema. Find max min. And then max min. Perfect. So, can anyone give us the formula for the revenue? Anyone?
Is it x times 500 minus 5x?
Very good. So x times y. So this is x. 500 minus 5x. I distribute and arrange it in the correct order. Negative 5x squared plus 500x. Perfect. I'm asked to find max min. In other words, in general we say relative extrema. In other words, find max min or relative extrema. Good. So what are the steps? What do I need to do first?
First, we need to find the prime of it.
Good. Can anyone give us the r prime?
Negative 10x plus 500.
Very good. What do I have to do in step 2?
That it's or 0 or undefined.
R prime of x is 0 or r prime of x is undefined. Remember, we may have critical numbers coming from both. We have to always check both. You can say, what are you talking about? This is a linear function, a polynomial. This is not possible. True, but I still have to investigate. So for this function, this is not possible. Okay, but here I have negative 10x equals negative 500, so x equals 50, and that is the price. Now, do I know? So this is the critical number, for sure. It's coming from this source. But do I know whether this is a max or a min? I have no clue. But I will. This is step 3. I will. Let me write it here, because I don't think I did. Yes, this is step 3. And I have to check. I have to check what is this critical number all about. It may or may not be a critical, it may or may not be a max min. Okay, so I have r prime, and I have r of x. And I have, of course, I cannot go from negative infinity, it's x price, right? Let's say 0 to infinity in this case. And this is 50. So can anyone plug in a number here between 0 and 50, including 0? 0 is fine, you can check with 0. And give me the sign. And a number to the right-hand side of 50, and give me the sign. And then we'll identify what is this all about?
Is that will be positive?
Awesome. And to the right?
It's going to be negative.
Negative. So what type of situation is this?
It's max.
It is a relative max. What is it? I don't know. The relative max will be R of 50. So I have to go back to R and replace 50 times 500 minus 250, because 50 times 5 is 250. 500 minus 250 is 250. And then I multiply, and I get 125 and 2 zeros. So 12500. And this is the maximum revenue. So I plugged in 50 in R to find the maximum revenue. This is only telling me where the function is increasing and decreasing and where it has a max or a min. It has a max at 50, 12,500. This is the point. This is just our analysis of the derivative of the rate of change of revenue that gave us all this information. But this is not the point. The point is 50, R of 50. Perfect.